this is 6.5, graphing linear inequalities. So we're going to graph these like they're in slope-intercept form. If we see anything with an equal to sign, we put a solid line. If it doesn't have an equal to sign, it's a dashed line. Okay, to start, we have this inequality. We're going to graph it. It's in slope-intercept form. So we start with 4. That's our y-intercept. Slope tells me to go down 1 over 1. And then since it has an equal to sign under it, it's going to be a solid line. Okay, with inequalities, we then have to figure out where to shade. To do that, we plug in a test point. We can use 0, 0 as long as it's not on the line. Okay, see how our line doesn't go through 0, 0 here? So we can use 0, 0. And really what we're trying to do is we're trying to figure out where on the graph ordered pairs makes the inequality true. So by plugging in 0, 0, we can figure out which side of the line has ordered pairs that make the inequality true. So when we plug in 0, 0, we just do the math. Is 0 less than or equal to 4? Well, this is true, so that means on this side, all these ordered pairs are true. So I'm going to shade if my test point, shade on the side where my test point's at, as long as it makes it true. So what this means is any ordered pair in this shaded region will make this inequality true. Now, if our test point didn't work, this side would have been false, and then we would have shaded here. But since it makes it true, you shade on the side that your test point's on. Okay, next one. Again, we just plot this, start with our y-intercept. Start at -4. And we can't really go down 5 over 3. Well, on your guys' graph we can't, so we're going to go up 5 to the left. 1, 2, 3, 4, 5. 1, 2, 3. And again, it has an equal to sign, so it's a solid line. And then plug in the test point. So we can use 0, 0, because our line doesn't go through it. Is 0 greater than or equal to -5 over 3 times 0 minus 4? Well, when I do this math, I'm going to get 0 minus 4, which is just -4. So is 0 greater than or equal to -4? That is true. So again, 0, 0 makes it true. I shade on the side that 0, 0 is on. Okay, next one. Oops. Might help if I started with x. Okay, this one, y-intercept's -2. Log point at -2. And then we want to go up 3 over 4. And then this time, there's no equal to sign under this, so it's going to be a dashed line. Again, we need a test point. 0, 0 is the best one to use. So is 0 less than -2? Okay, that would be false. So that means 0, 0, the side that 0, 0 is on, doesn't work for this inequality. So I need to shade away from 0, 0. This side's false. I want the true side, which would be below the line. Okay, next one. Now we're going to be given some that aren't in slope-intercept form. So we've got to put them in slope-intercept form. Remember, slope-intercept form is y equals mx plus b. So we solve for y. Subtract 7x. And then we divide by -2. And there's a rule with inequalities. When we divide by a negative, we flip the inequality sign. And then we take each of these terms divided by -2. -7x divided by -2 is just positive 7 over 2x. -8 divided by -2 is just 4. So then we graph this. Start at 4. And we're going to go, I could go up, I can't go up 7 over 4, but I can go down 7 to the left 4. And this would be a dashed line because there's no equal to sign under it. Okay, again, plug in 0, 0 as your test point. Is 0 greater than 4? That would be false. So 0, 0 is here, that's false. I want to shade on the other side of the line. Okay, try one more. So, again, we got to put this in slope-intercept form. So we move x first, minus x. Divide by -1. So when we divide by a negative, we flip the sign. So is 0 greater than or equal to 1? That would be false. Okay. So we know we're not going to shade on the 0, 0 side. This will be a solid line when I graph it. And we don't want the 0, 0 side because we made it false, so I shade above.